to be done with chapter 3, which is our chapter about logic. So, chapter 3 about logic. Real quick, I need to pause. Anywho, back to what we're learning about in chapter 3, truth tables. Last time we pretty thoroughly covered the case where you start off with two initial statements, P and Q. Remember, in your first column here, you have to declare all the possible truth value combinations of the two. If you throw a third initial statement in there, R, remember we argued that doubles the number of rows that you need on the table. Every new statement you add doubles the number of truth value combinations. So this will be the new first column, if you will, that we're going to have to declare. What you do is you repeat the original column for the Q and R part, TT, TF, FT, FF. TT, TF, FT, FF. You duplicate it, and then for P, you make it all true in the first four, then all false. So this is a nice little pattern to remember. But just because we add a third statement into there, it really all still works the same. Your ands work one way, your conjunctions. A conjunction is only true if both parts of it are true. A disjunction is only true if at least one of the two statements is true. Negations still work the same way, nothing wild and crazy. So if you have the statements P, I study hard, Q is the statement I ace the final, R is the statement I fail the course. Let's look at this statement, I study hard and I ace the final, or I fail the course. I study hard and I ace the final. There's a comma. So that tells me all this is to be taken at once and put in parentheses. So it's P and Q or R. Oh. Let's fill out the truth table ourselves. Let's figure out what it would be for this case. So we're going to fill out our own truth table here. The truth table filling out is for the statement P and Q or R. There's only two computations here, the AND computation. Once we do that, then the OR computation. And let's zoom in some more so we can make it nice and large on the screen. Okay, so let's do it one by one. We have PQR. We're going to use these combinations of truth values. The first computation we need to do is P and Q. The only things we look at are P and we look at Q. The only way P and Q is going to be true is if both P as well as Q are true. So P and Q, let's see. Oops. P and Q, we've got a true and a true statement, which is true. We've got a true and a true statement, true. True and a false statement, false. In fact, the rest of this column will be false, won't it? True and false, false. False and true, false. False and true again, false. False and false, definitely false. False and false, definitely false. So you just need a new column for each separate computation you have to do. All right, now we're going to do the whole thing. We're going to do all of it. we need the P and Q column, which is this column that we just calculated, the P and Q column. We are doing the OR computation with the R column. So these are going to be the only two columns that we're really going to care about right now. And then we just need to do the OR computation. Remember, the OR computation is true when at least one of the two pieces it's composed of is true. The only time the OR computation will be false is if both of them coming into it are false. So we've got a true or a true statement, which is true. We've got a false or a true statement, which is true. True or a false statement. False or a false statement. False. True or a false statement. True. False or false. False. True or false? True. False or false? Very good. And that's all there is to it. We've just filled out the truth table. Now, let's say in reality, P is true, Q is false, R is true. And if we remember, those were the statements, and P was the statement, I study hard. Q was the statement, I ace the final. R is the statement, I fail the course. So, if reality is that P is true, that means I'm going to study hard, I'm not going to ace the final, and I'm going to fail the course. Is that a true statement? Well, let's find out. Let's get everything back where it belongs. Oh, one too far. There we go. Well, let's see. In reality, P is true, Q is false, R is true, so we need to figure out which row that is. Let's see. P is true, Q is false, R is true. So this is the reality right here. And when that's the case, then the statement P and Q or R is a true statement. So we've just by adding R into the mix, it doesn't really make anything more complicated. It makes a larger table, but all the computations are exactly the same. They're not any more difficult. It's just like saying 2 plus 3, and then you also have to do 2 plus 3 plus 5. Big deal. That's just one more thing you got to do, but it's not, the process is exactly the same. Okay. Beyond that, we don't necessarily have to go too far down the rabbit hole with this. Just a quick note, one other way that you can do truth tables, let's say you're like, you know what, I don't want to make an entire table, get out of here. Let's say I know from the get-go that whatever my statements P, Q, and R are, let's say P is true, Q is true, and R is false. I already know that. The table tells me that no matter what combination of true and false they are for P, Q, and R, I can figure out the conclusion. But if I already have a specific value for P, Q, and R, I don't want to have to write out a table for every possible other value those could take on because I know what they are. In that case, why make an entire truth table? Here's what you can do. You can substitute in the truth values that we know. For instance, in this fairly complicated logical statement, not P and Q or not R. I can substitute in the fact that P is true, Q is true, R is false. And now I just kind of do the computations one at a time. I make sure to follow dominance of connectives in parentheses and the like. So I can start here. A true statement is true. So then I'm just left with not a true statement or not a false statement. Now do the nots. Not true is false. Not false is true. So I'm left with a false or a true statement, which is true. I can kind of break it down like that. I'm still doing the same thing if I made a table, except I only have to do 1/8 the work. I'm not doing every row on the table. I'm just looking at one single row. This is kind of like when you're given an algebraic expression with like X and Y in it, and you're told plug a 3 in for X, a 2 in for Y, and a 12 in for Z. And that way you can just do it for that one specific case for those values. So it makes your life a little easier, but you can always make a truth table. I can make an entire truth table for this whole expression, then look at the row where P is true, Q is true, and R is false. Any questions out there, either in the room here or in the Zoomosphere? Any questions on logic? Because that's it for chapter 3. That's it for chapter 3. So how many of you, whether you're out there in Zoom, whether you're here in class, how many of you looked at what we did in chapters 2 and 3 and said, that's not math? Raise your hand. You can be honest. You said, that's not math. Now, I've already gone on a tirade about this, or not a tirade, but a rant about it. And I said, look, all this stuff we're doing, all this logic and symbols and things that don't look like just numbers and crunching numbers is actually more about what math is truly on than just crunching numbers. Crunching numbers, frankly, while it can be difficult at times, crunching numbers is the result of some of this higher level mathematics that went on behind the scenes before we could even talk about crunching numbers. You have to develop an entire system of logic here in order to dictate how mathematical operations work, like addition, subtraction. They're all based on logic at the end of the day. So it's really cool that this is my favorite math class to teach. I love it. I have a background in statistics, and I teach the statistics courses, but there's something about those courses that I never quite feel like I'm in a groove with. But for this course, and I don't tell my statistics students that, it's not like I don't lecture well, I think. It's just that I'm not like super excited about the content. This class, I get super excited about the content. I love talking about logic and truth tables. You might think it's nerdy, but I think, okay, that's like, this isn't middle school or high school anymore. We're adults, and to be able to think this way is a very valuable skill that can help you in almost every avenue of your life. Thinking logically and critically, are you kidding me? That's how you can rise up through a corporate structure at a company. They want someone who can think logically, and this kind of stuff can help you to do that. It's not the only thing. There's other skills you need, but it's just one extra little feather you can put in your cap that can help you to be a better, smarter thinker, frankly. And that is valuable to every organization on the planet, whether you are part of a criminal organization, whether you're in the mafia, or whether you're just working for a bank. So good stuff. But that's all she wrote for chapter 3, and we say farewell to it. And I say, chapter 3, we hardly knew ye. For some odd reason, we do chapters 1, 2, and 3 from the textbook. Then we skip to chapter 8. Then we do chapter 9. Then we skip chapter 10 and do chapters 11 and 12. Why do we do that? It just so happens that's what this course, the material this course requires, and we found a book that just happened to be those chapters. So we're going to skip to chapter 8. We're not really skipping anything. We're just going to the next thing we want to do in this course. And whoo boy, it's a doozy. It is a doozy. Y'all ready for it? Maybe? We'll let the thing fire up. Personal finance. Everybody say yay. Everybody in here, you can say yay, you can clap. There we go. How many of you are excited to learn about personal finance? Honestly, you may not actually be that excited. You may have said that with a little shred of sarcasm, undertones of your voice. But personal finance, my goodness, if you know how to manage your money, if you know how your mortgage payment is calculated if you buy a home, If you understand how savings and saving over time and investing your savings can end up with millions of dollars for you to retire on 30, 40 years from now, whatever, those are all so fundamentally important. And so I really do believe in what we teach in this course. I really do. This is the most real you can get, even though ironically, we just learned set theory and logic, which look like a bunch of pie in the sky nonsense. It's actually not. It's just that you may not have ever thought about the world in this way. But personal finance, you can't argue against this stuff. This stuff is important to understand. And I truly believe that. That's a Josh Gunther guarantee. Now, here's the wonderful thing. Chapters 2 and 3, we really didn't need a calculator, did we? No, there was some weird logic problems that were like, P is the statement, 2 times 3 equals 5. But that's not like a tough math question that you need a calculator to grind out the results. Here, though, absolutely, we're going to need our calculators. So pretty much for the rest of the semester, whether you're meeting in Zoom or whether you're meeting here in person, bring that calculator. You're going to want a scientific calculator or better. For the rest of the semester, you'll need, rather, a scientific calculator or better. The classic scientific calculator is the TI-30X2S calculator. That thing is sold everywhere. That is literally, I'm pretty sure, if you fell down a hole in the middle of France and you're in the middle of nowhere, you'd fall into a giant cave of TI-30X2S calculators. Those things are everywhere. We sell them at the Weatherford College bookstore. You can buy one on Amazon. I'm pretty sure in some countries they're even currency because this is the most common kind of scientific calculator there is. So look for that one. That thing's going to have everything you need for this course on it. You can use a graphing calculator. A graphing calculator, the TI-83/84 graphing calculator is the gold standard. The gold standard. Why? Because it does everything you need. It does everything we need for this course, but you get like a nice big screen. And if you get a newer one of the TI-83/84s, it'll even deal with exponents and parentheses and put them where you want them. So the TI-83/84 graphic calculator, beautiful. You cannot use, what do they call them? The TI Inspire calculators because they have internet connectivity. You can't use them on an exam because then you can surf the web or whatever you call it. You cannot use your phone calculator. No, I guess you can do it on the homework, but on exams, you cannot use your phone calculator. In fact, for the next exams, starting with exam 2 here, I'm going to have you flash your calculator at me. Just show it to me on the screen real quick. And if you try to put your cell phone up or something, that might just invalidate the results of your exam. So those are the two. I would just, the TI-30X2S is like 15 bucks. Amazon, Target, Walmart has it. The graphing calculator, you can probably get a used one on Craigslist. Make sure whoever you meet, you do so in daylight in a crowded-ish area. I bought, when I was in high school, me and some friends, we bought a video card for a friend's computer from some guy. We met in the middle of this dark parking lot in the middle of nowhere. And in that particular case, it was a real transaction. It was just weird that we were meeting there. But normally I would say don't meet somewhere that it's creepy looking. But yeah, so if you buy a brand new TI-83/84, boy, those will run you. That's at least $100 you're looking at. That's for brand new. This calculator's been around for so long, so many people have used it. You might be able to find one on Craigslist, 15, 20 bucks, eBay, something like that, if you want a little bit more powerful of a calculator. Yeah, and we won't really need it today too horribly much. Most of the computations we'll do today are just in the future. I would just bring it Technically, you don't have to have it during lecture. It's just if you want to follow along and punch the buttons in yourself, then I would suggest having it. But yeah, you don't necessarily need it today. Now, you get to use a calculator. So converting between percents and fractions and decimals is all super easy. If you have a fractional number and you want to express it as a percent, well, a fraction is literally one number divided by another. The numerator is the top number, and it's being divided by the denominator. So in your calculator, you can literally do 3/4, do 3 divided by 4. It will give you a decimal point. Let's do a couple examples. Let's say you have 3/4. Put that thing in your calculator, literally do 3 divided by 4. You will get 0, perhaps they'll put the 0, perhaps they won't. You'll get 0.75. So this is the number in decimal form. If you want to go to a percent, you move the decimal point 2 places to the right. So as a percent, 3/4 is 75%. Um, 5/7. No, let's do it. 5/7, you're going to run into a problem. Not a horrible problem. I'll do it on my calculator here. Now I'm using my phone because I'm allowed to. It's real convenient for me. 5/7 is funky because it keeps going. As the Prophet's Limp Bizkit once said, it keeps rolling, 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 rolling. That thing keeps going and going. Your calculator will stop at some point because it can't display an infinite number of digits, and hopefully you understand why. But what do I do here? Well, this is just kind of a matter of personal preference. In this case, I'm just going to round to 3 decimal points. Thus, I need to use technically a squiggly equals line, which means about equal to. And then I'll get you in one sec. And then we'll convert it to a percent. We'll move that decimal point 2 places to the right, and now we have 71.4%. And so it's just a matter of how much precision you want. Yes. Calculator. Yeah, if you can literally just do 5 divided by 7 in the calculator. 3 divided by 4. So what you can do since we're in class, you're not on an exam, you can bust out your phone calculator if you want to do some of these with me. So literally on your phone calculator, you literally just do 3 divided by 4, hit equals, and it should give you 0.75. Same for 5 divided by 7. 5/7, 0.714285. So you got to round it some. Thus, converting from a decimal number to a percent is just multiplying by 100. In other words, move the decimal point 2 places to the right. That's the beauty of multiplying by 10, 100, 1,000, 10,000. We live in a base 10 number system, so multiplying by those is just moving the decimal point however many places is appropriate. If you want to go the opposite way, converting from a percent to a decimal involves dividing by 100. In other words, move the decimal point 2 places to the left. And there's only going to be 1 decimal point. So That's how we go from one to the other. Right. So basically, 0.51 written as a percent, I move this thing 2 places to the right, 51%. If I have 60%, you don't see a decimal point written there. That means it's secretly hiding right there. And we move this thing 2 places to the left, and it's just going to become 0.6, and then you can put a 0 at the front. That 0 that was there originally is no longer significant, so it can go as well. Yeah, so if you want to think about it like this, again, the dividing by 100 is almost semantics. That's what's secretly happening. But if you just remember to move the decimal point the right number of places, then you'll be fine. But technically, 60%, right, percent literally means per 100. And even further, the word per means divide. So if I'm saying 60%, I'm saying 60 per 100. 60 divided by 100. And thus, as a decimal, 60 divided by 100, you can pop that in your calculator if you don't believe me, will give you 0.6. So converting between a percent and a decimal number is literally just moving the decimal point twice in the correct direction, depending on where you're trying to go. If it helps, a percent is literally supposed to be 100 times the regular number. So it's a percent is going to be 100 times larger than its underlying decimal value. 60% is 100 times 0.6, if you want to think about it like that. So moving the decimal point is the key. So, very simple stuff so far. Percents are very, very important to understand in the world. So many things are expressed as a percent. If you get an interest rate, which, hey, we're about to do interest rates here. If you get an interest rate, you're going to have it expressed as a percent almost exclusively. So if we wanted, let's say we start with 19%. We want to express it as a decimal. The decimal point is secretly right here if you don't have one otherwise written. Do I go 2 places to the right or 2 places to the left? To the left. Because moving it 2 places to the left will make it appear to be smaller. And it's going to be 0.19. And sometimes we like to put a 0 to emphasize where that decimal point is. So it's just symbols. Even something like 180%, wait, can a percent be larger than 100? Yes, it just depends on your context. If you're gambling and you bet $10, let's say you bet $10 that Tom Brady would throw 3 touchdown passes in the Super Bowl. Well, in gambling terms, let's say you bet $10, and if you're correct and you win $18. You get your $10 back, plus you get an additional $18 in winnings. You won more than you bet. If you express your winnings as a percent of your original bet, you would say, I won 180%, or I made a 180% return on my investment. So, and percents can be greater than 100. It just depends on the context you're talking about. If you're taking one pie and cutting it into slices, all those slices must be less than 100%. But if you're talking about growth beyond an initial starting point, you can definitely go over 100% any day of the week. If I grow from 2 feet tall to 6 feet tall from age 4 till age 20, I've tripled my size. And what that means is I've actually grown by 200%. I take 200% of my original size, then I add it on and I get up to 6 feet that way. So you can absolutely have a percent that's beyond 100. It just depends on context. How many of you have been reading about GameStop in the news the past couple of weeks? Do y'all know what happened with GameStop? Yes and no. Long and short, what happened with GameStop, we're talking specifically about their stock. GameStop's stock value, it went up by, I think it went up by 30 times over, meaning if it was like, I think it was selling at, I don't remember the exact numbers, but if it was selling at $10 a month ago, it went up by 30 times and it's now selling at $300 a share, which is absurd. It is absurd growth. That translates to 3,000% growth, which is ridiculous, but that is what happened. So a percent can go beyond 100, you bet. No questions asked. So if you had 180%, you're still going to move it 2 decimal places to the right. Don't move it 3 just because that would make you feel good. Move it 2 no matter what. You're going to end up with the number 1.8. And that's all there is to it. So don't let percents scare you. Another thing you're tempted to do, let's say you start with, I don't know, 0.632%. And let's say we want to convert that to a decimal. Now I know what you're tempted to do. You're tempted to move it 2 places to the right, aren't you? Because if you move it 2 places to the left, you're going to get a really tiny number, aren't you? Raise your hand if, yeah, I would think to move it. No, you don't get to choose. It's just a really, really small number at the end of the day. And you have no choice over it. No matter what, if you're going from percent to decimal, you move that sucker 2 places to the left, whether you like it or not. 1, 2. What do I fill in for empty spaces? 0. So this becomes 0.00632, which is a tiny number. You can even put a 0 before the decimal point as well to emphasize where it goes. So you don't get to pick which way the decimal point moves. It's fixed. Same with vice versa. If you were going from a decimal number to a percent. Let's do a little aside. Exactly. Yeah, and you'd go 2 places the opposite direction. So if you started with a decimal number like 3,700, that's a decimal number, right? Because I don't see a percent sign there. So let's convert this to a percent. Secretly, the decimal point is right here, because if there isn't one written, if you're just talking about a whole number, the decimal point is secretly at the end. Now we're converting to a percent. Do I move it 2 places to the left because that's what my heart tells me to do? No, you move it 2 places to the what? You move it 2 places to the right. Whether you like it or not, you're converting to a percent. You fill these in with zeros, and that's going to be 370,000%. That's huge. That's a huge number. So, you know, if you look at some companies like Apple, Microsoft, some of the big names out there, we call those blue chip stocks today because they're likely to not fluctuate in value too horribly much. They're likely to just be like a solid, firm investment over time because they're the major players. You're not investing in some nobody. You're investing in Microsoft or Apple. I bet if you bought Apple stock in like the 1970s when they were starting to really become a thing, you could have maybe bought for $2 a share back then. Their share value could be worth thousands of dollars today. Now, that may not be exactly what's going on, but the idea is you can get 370,000% growth on a long-term investment for a company that blows up and just becomes absolutely huge. 50 years ago, 40 years ago, almost nobody knew who Apple was and nobody cared, even though they were puttering around. Nowadays, who doesn't know who Apple is, right? Everyone knows the iPhone, that's really their biggest thing, the iPad, and Microsoft. Everybody knows who Microsoft is. If you don't, you're probably not using a computer. You're probably not, which has Windows on it, which is Microsoft. So 370,000% is a massive number, but there are things that may just well be measured in that. Now, what we need to talk about is something called the percent formula. It's great that we can talk about percents in theory, that we can talk about converting between a decimal and a percent. But at the end of the day, we are going to want to take percents of other numbers. What do I mean by that? Well, let's say you've got $1,000 sitting in your bank account. $1,000 sitting in your bank account, you're feeling good. You maybe are thinking about buying a PS5 in 3 years, whenever we can all get our hands on them. You're thinking about going and buying something with that $1,000, and then someone comes along and says, hey, remember that debt you owe me? You owe me 60% of what's in your bank account. Well, that sucks, but you need to be able to take a part of the whole, the 1,000, and cut it up into percents and take 60 of those percents and give them to me. 60% of 1,000 will be $600. So you're going to have to give me $600 and you get to keep 400 of it. That sucks, but that's life. Whenever you work a job and you get, if you work a W-2 job, you get your W-2 is your form that dictates how you're paid and what gets taken out of your paycheck. It's ultimately a tax form. What your W-2 does, whenever you get your paycheck, it will say, hey, we took 6% of your pay out for Social Security. We took 10% of your pay out for federal income tax withholding. Excuse me. So what you do is you may earn, let's say you earned $1,500 on your paycheck. You got a 2-week paycheck, $1,500. That's not a bad little amount of money to be walking home with. But you're ultimately, you get the thing and it's only for $1,127.86. What the heck happened? I thought I was getting $1,500. They took some of your money out for different reasons: taxes, Social Security, FICA, and there's other things depending on your situation. If you have any wage garnishment, if you lost a case, a civil case with maybe a divorce, or if you owed a debt to someone and they garnish your wages, meaning someone literally comes in and takes a percent of your paycheck. That is important to understand a percent so you know that you're not getting cheated, so you know that everything is working the way it should be. So percents are fundamental to our understanding of finance and dollars. This is the percent formula. And what it does is it teaches us how to take a percent of something. B here is going to be the thing that is kind of like the whole pie that we're going to be taking a slice out of. P is the percent of the whole that is going to be the slice that we're going to take out. And A is going to be the actual size of the slice. There are all kinds of ways that you're going to be using this percent formula in life. A equals PB. So let's see how it works. A equals P times B. Let's say you make $1,500 per paycheck. Maybe that's a 2-week paycheck. And your employer takes out 10.4% of that for taxes, basically. Now, what you find out, you might get some of that back later when you file your taxes for the year. It depends on your situation. How much is coming out of your paycheck for taxes? 20%? Yeah, and that just depends on your situation. The thing is, if they're taking out 20%, and after you file your taxes for the year, it turns out you should have only been paying 12% in taxes, you're going to get the difference back in the form of a refund when you file your taxes. So literally taxes are going to be section 8.2 that we're going to cover. But I get so excited talking about taxes because I want to help you guys save money. When you pay your taxes, There are legal ways that you can reduce the amount of money you owe the government, and you should take advantage of every single one of those legal manners. 20%, it sucks, yeah. 20% is coming out of your paycheck for different things. It's like, that's my money, right? And we all have different political views and feelings about taxes, but we can at least understand the math behind it. That's important that we understand the math behind it. So you make $1,500 per paycheck, but 10.4% is taken out for taxes. So A, P, and B. A is going to be what we're looking for. A is going to be how much is coming out of the entire pie. We don't know that right now. P is going to be the percent, but there's a twist. Whenever you actually have to do math with percents, whenever you have to do mathematical computations with percents, you pretty much always express them as decimal numbers. Whenever it's come down to put it in the calculator and crunch those numbers, it's got to be a decimal. So what is 10.4% as a decimal? Perfect, 0.104. We move this sucker 2 places to the left. I put an extra 0 before the decimal point for emphasis. B is going to be kind of the thing we're taking a percent out of. So what's B going to be here? Well, the $1,500 in our paycheck, because we're taking 10.4% of that. Well, in this, dividing may come up. It depends on the context. It depends on what you're doing. In this case, we have the formula A equals PB. We don't know what A is, so we'll rewrite the formula by substituting in the values we do know and solving for the missing value. In this case, we both know what P is. It's got to be the 0.104, and then we're multiplying it by the 1,500. Guess what? Do you have to do that in your head? Do you have to come out here and do that the old school way? Do you have to do it this way? No. The good Lord gave us calculators, and you better bet we're going to use a calculator every chance we can get. This is a class where you get to use the calculator. Now, I have feelings about calculators, but you know what? Who cares about my feelings? The policy is you get to use the calculator. So bust that wonderful thing out. You can use your phone calculator right now. Right now, bust out your phone calculator and do 0.104 times 1,500. I'll do it as well. What do y'all get? 156, exactly. So every paycheck, which makes sense because 10% of 1,500 is 150. So it's just a little more than 10%. So $156 is coming out of your paycheck. The good news is if by the end of the year, you actually only owe the government 6.3% of your salary in taxes, you're going to get a refund. You're going to get that money back. Of course, I could have kept that money the whole time, paid the government later, and in the meantime, invested that extra money that I had and earned a little interest on that. Wait a minute. Your company will automatically withhold taxes for you. And maybe that's a good thing if you know you're not great with managing your money just yet. Maybe you just haven't really figured it out for yourself. There's nothing wrong with that. But if you're at a point where you have every dime, every dollar, every penny accounted for, and you know what you're doing, you could technically ask your company not to take out any money for federal income tax withholding. Just tell yourself, I'm going to owe taxes. Whenever I file my taxes, I'm going to owe the government money because nothing has been taken out already. But in the meantime, the extra money I'm getting, I can invest it and do more things with it and just pay my taxes later. But the government does not suggest you do that because if you come up short, there's all kinds of things you're going to have to deal with. And I don't even suggest it unless you're just super whiz with your money. So every paycheck, $156 is coming out for income taxes. What did Benjamin Franklin say? There are only two certainties in life: death, we're all going to die, and we are all going to pay taxes. That's a famous quote by Benjamin Franklin. Another place where you'll see where you will see taxes and percents come up: sales tax. Sales tax is a state tax, meaning if you go buy $100 of goods and there's an 8.25% sales tax like there is in Texas, then you're going to have $8.25 tacked onto that, and you're going to pay a total of $108.25. Those $8.25 that you're paying in sales tax go to the state of Texas. So sales tax is usually a state tax. That's how the state raises money for its activities. So sales tax is a place where you'll see that. We can leave the percent formula up. Heck, we can leave all this up. We'll do a basic example. Let's say you buy $347.56 worth of video game stuff, games and controllers and a little thing to put on your controller, grips to help you when you're playing your first-person shooter games, and you need that extra precision when you're sniping. Energy drinks, yeah. Doritos, Mountain Dew, these are all the signs of a great and wise and powerful gamer. Yes, eating crappy food and drinking highly sugar beverages. Am I telling you you're not allowed to do that? No, because look what I'm drinking. I'm drinking a full throttle. You know how much sugar this has? 55 grams of sugar. I'm pretty sure that's more than what my doctor wants me to have in a single day, and I'm drinking it all in one can. You know why? Because I live in the great United States of America, and I will put sugar into my body at really, really unsafe levels, and I will pay a price for it later, but not today. Not today. But anyways, so you buy $347.56 worth of video game stuff. How much will you be paying in sales tax? Assume an 8.25% rate as it is in Texas. That's how much we charge in sales tax in Texas. How much total will you be paying? So we're going to start by figuring out how much in dollars I'm going to owe in sales tax. What should I do with the sales tax then? Well, we'll do that with the sales tax rate. Once I calculate how much dollars I'm going to pay in sales tax, what do I do with that amount? We'll add it on to how much you're paying. Yeah. So first of all, we'll answer this first question. How much do we pay in sales tax? Well, A, we don't know. A in this case is going to be 8.25% of $347.56. P, the percent, is 8.25%, but don't forget to convert it to a decimal. 0.0825. B is the entire pie that I'm taking a percent out of. It's going to be what I'm paying. So I'm literally going to do 0.0825 times $347.56. What will that give me? 28.67, round to 2 decimal points. What was the third decimal value? 0.37? Okay, so got it. So it was 0.6737. But since this is money, we're going to round to the second decimal point. We look one place to the right, we're going to be rounding down. Don't just truncate. In this case, we rounded down. Truncating means just delete everything after your decimal point. Don't do that, round. But in this case, 2867. So here's the skinny. On top of the $347.56 we're already spending, we have to pay an additional $28.67 in sales tax. So how do we figure out the total? Add them together, exactly. So we're paying $28.67 in sales tax, but if we add them all together, let me move this over. $370 something, yeah. That's what we'll get. If you add them together, the 347.56 plus the sales tax, this is how much we're literally going to be spending out of our pocket. So 376 and 23 cents. And that's a dollar sign in front of it. That's how much is literally leaving our pocket to purchase $347.56 worth of goods. That's a lot of Mountain Dew gamer fuel, bro, as it is often said. Some quick good news. Generally, there is no sales tax on grocery items. This is actually something I didn't know until the last couple of years because I just never really looked at receipts. But if you go to any store, when it rings stuff up, it knows this is a grocery item, this is a grocery item. Oh, this is a video game? No, it gets sales tax. But the receipt, the system automatically puts tax on for certain items, but not for grocery items. So it's not always so cut and dry. And that's, of course, because we all need groceries, and the government doesn't feel like it's wise to tax something that is just a necessity. In some states, right. I think Texas is one of them that does not tax on groceries. But other states have different rules. Dang. Mm-hmm. Yeah, and if you buy all your groceries at once, it seems expensive, but depending on what you're buying, generally buying in bulk saves you money in the long run. If you buy like a bunch of cans of SpaghettiOs, they might give you a discount because you're buying so much. As long as you will eat all the SpaghettiOs, it's good. If you buy in bulk and then you waste more than half of it, you probably actually should have just been buying smaller units. But HEB, that new one in Hudson Oaks, yeah, that's nice. I have not been to it yet, but I've been to other HEBs and they're really nice. Yeah, it is. Yeah, it definitely is. Especially right now, it's like I don't want to go out with large crowds of people. I'll just order it all online because I am lazy. That's not true. Okay, so we can think about percents in terms of that. We can think about percents in terms of discounts. Discounts happen all the time. A sale, 20% off sale. What does that mean? That literally just means whatever the original price is, you calculate 20% of that, and then you subtract it off from the price. And now that's what you're really paying. But then sales tax will still come in after that for something that has sales tax. That's the best. Mm-hmm. So, yeah, same with the Sony store. Yeah, again, PlayStation, they have all kinds of sales they're always running. So you want to buy some nice tennis shoes that are 65% off. That's not bad. Maybe it's some kind of special Memorial Day sale, whatever. The original price of the shoes, now they're nice. You can spend $350 on some shoes. That certainly exists. How much total is being discounted? In other words, how much are you saving? What will your price be after the discount? Once again, we can use our A equals PB formula. Yeah, it's not a horrible amount. I mean, you're still getting some good shoes. The percent is 65%. Remember, we convert that to a decimal. B is going to be the $350. A, we don't know. 0.65 times 350, what does that give you? You're going to be getting $227.50 off. This is what you're saving. It's how much you're getting a discount for. Yeah, that's the discount amount. That's how much we're cutting off the price. So the actual amount we're going to be spending, we need to subtract off the 227.5, which should give you 122.50. Yep, that's not bad. You're getting almost 2/3 off. This is what our actual price will be. Now, of course, then we have to tack sales tax onto that because shoes are almost certainly going to have sales tax on them. Of course, there are special weekends that are tax-free, meaning anything you buy, there's no sales tax charged on it. It's usually the weekend right before school goes back. And that's just so parents can buy school clothes and supplies, and it usually is a really big sales weekend for a lot of stores. We can talk about all this stuff. One more thing I'll look at. Let's do another example. What percent of 375 is 84? Ooh, a real thinker. A real thinker. We've got our percent formula. Now, yeah, exactly. The P, well, you can do it that way. Yes, you can do it that way. We'll just do it with the percent formula because we can use calculators and it comes out the same either way. P is going to be what we don't know. So when I write out my A, my P, and my B, A we'll know, P we don't know at the moment. What percent of 375 is 84? So 84, now it's not just because it's the smaller number. It's because we are taking a percent of 375. So 375 must be what we're taking a percent of, thus it's B, and then A must then be 84. Now on the sly, I actually could have written it like this. What percent of 375 is 840? That would just make A 840. That would make my percent greater than 100%. So be careful. It's not just the smaller number and the larger number, because your percents can go beyond 100%. You need to read the problem carefully so you know what to do. But we did 84 originally. What percent of, well, set up the formula. 84 equals P, which we don't know, times 375. Yeah, you would, exactly. You would divide both sides by 375. This is just simple equation solving in order to get P, 84 over 375. Let's use our calculators and do that actual division. You'll get 0.224. That's the decimal number. How do we convert that to a percent? So then as a percent, that's 22.4%. And technically that's what we're looking for. That's going to be our final answer. All right, don't go anywhere. I'm going to take attendance, but that's a good stopping point.